Let's say I have a graph of a function. We'll use x squared for this example. So f of x equals x squared, and that's the graph I already drew. If I want to find the value of this function as x approaches 2, meaning as x gets closer and closer to this 2 point over here, I have to see what my function does as I get closer and closer towards it. In math, we can write this as the limit, or we write lim, the limit as x approaches, and this little arrow, 2 of x squared. And we have to evaluate this. Now, many of you might have already guessed or just brilliantly noticed that we can just plug 2 directly into our function here, and what we get is 2 squared is 4. And so that 4 is what our function moves closer and closer towards as we approach this x equals 2. Now, you're probably thinking to yourself, well, why would we write it like this? Why wouldn't we just say, what is our function evaluated at 2? Like, isn't that the same thing? In this case, yes. In this case, it is the same exact thing, but there's a lot of times where you'll run into issues. So let me show you another example. So let's say we take the limit as x goes towards 0, so as x gets closer and closer and closer to 0, but doesn't quite get there, of the function 1 over x, then what happens? Well, let's look at our graph. And 1 over x is something like that. So as x gets really, really, really big, this becomes really, really small. Or as x gets closer and closer towards 0, what happens? Now from the graph, it's kind of hard to tell. You can't see all the way up here. So what happens when we just plug 0 in? So if we plug 0 in, we get 1 over 0, but that's undefined. We already did that in our other math classes. So this is undefined, and you might be able to just think, oh, well, that must be the answer to this question. But no, if you were taking a calculus test and they said, what's the limit as x approaches 0 of 1 over x, and you wrote undefined, you would get it wrong, because we're not just directly plugging in 0. In this old case, we were able to do that because it didn't cause issues. In this case, we tried it, we saw it gave us 1 divided by 0, so now we have to go back and say, okay, I can't just plug it in, what can I do? So in this case, we look at values that get really, really close to 0. So let's go ahead and take 1 over 1. So we'll say x equals 1. Now, our function is 1 at that point. Okay, nothing problem there. So let's get closer to 0. So we say 1 over 0.1. So 1 over 1/10. Now that gives us 10. All right, so let's get closer to 0. 1 over 0.001. I went 100 times closer, right? So that gives us, what would that be? 1, 0, another 0, so that'd give us 100. I believe I did that right. And so, no, I'm sorry, that would give us 1,000. There we go. So, all right, what happens if I just keep adding more zeros? 0, 0, 1. Well, what happens is I get a really large number with a bunch of zeros. So I'm realizing that as my x, the bottom number here, gets closer and closer and closer to 0, my function of 1 over x is going towards infinity. Now that is not the same thing as undefined. Those are two completely different answers. And that is actually what the answer is in this case. If you say x approaches 0, 1 over x, the answer is infinity. So these are two different ways to solve limits that we've looked at. We start off with the very obvious approach, which is just take whatever it goes to, plug it into your equation, and see what happens. If you just get a number like this, then that's perfectly okay, and that's the right answer. Sometimes you have a dividing by 0 problem like we did in this case, and you have to take alternative routes. So in this case, the second step is we can do it numerically, where we just get our number, we take a random x and we move it really close to its limit, and we see what happens to the numbers.